Hi folks, this is Nat, and this is going to be your video lesson on identifying triangles by their angles and sides, and also finding the missing angles of triangles. There's some specific angle rules that go along with all triangles, and we're going to look at those and see how they can be used to find missing angles when we need to. You may already be familiar with the different types of triangles, but we're going to review them just in case you aren't. Triangles can be classified in two separate ways. The first and probably easiest is by their largest angle. As hopefully you know, all triangles are going to have three angles inside of them. That's literally what triangle means, three angles. And we can classify triangles by what type of angle their largest angle is. And here we've got three examples of triangles. As I look through, if I'm going to classify a triangle by its angles, I really don't care about anything except the biggest angle. If I look at this first triangle, the biggest angle is going to be this one right here, the 90-degree angle. And a 90-degree angle is a right angle, and so I would classify that triangle as a right triangle. Similarly, here in the center, we've got a triangle where the largest angle appears to be more than right, past right, so that's an obtuse angle. And so I'm going to classify that triangle as an obtuse triangle. This third triangle is a little bit funky in that it's maybe a little difficult to tell which is the biggest angle. You might think, well, maybe it's this one, or maybe it's this one. It doesn't really matter in this case because I can see that none of my angles are bigger than 90 degrees. This triangle is made entirely of acute angles. So the biggest angle is going to be an acute angle. So this is going to be an acute triangle. So this ends up being a pretty quick and easy way to classify triangles by largest angle. It's important to note that all triangles have acute angles. In fact, all triangles have at least two acute angles. So if we look up here at my right triangle, it may have that big right angle, but if we look here and here, we see that there are two acute angles as well. In my obtuse triangle, I've got acute angles here and there. And in this acute triangle, it just happens to be that I may have a largest angle, but I have two additional acute angles too. Some students get confused and think, well, if I see an acute angle, it must be an acute triangle. But remember, in classifying this way, we don't care about all the angles, two of which will always be acute. We care about the biggest angle, which might be either right, obtuse, or acute. So the only way that you get an acute triangle is if all three angles are acute, including the biggest one. Otherwise, if you see a right angle, it's right. If you see an obtuse angle, it's obtuse, because you'll never see more than one right angle or more than one obtuse angle in a triangle. The other way to classify triangles is by how many angles or sides are the same. And just like by largest angle, there are three different classifications you can end up with. For example, in this first triangle on the left, which appears to be a right triangle, it doesn't have the symbol, but maybe it's a right triangle by largest angle, it looks like this is the smallest side. Then you've got this side, which is a little bit longer, and then this third side here is again a completely different length. This is going to be an example of what we call a scalene triangle. A scalene triangle has no sides the same. And I'm actually expand on that definition because if no sides are the same, no angles in the triangle will be the same either. No sides or angles the same. Our next triangle over appears at least to have the two long sides here the same length, and one side shorter on the bottom. This is going to be an example of an isosceles triangle, which is hard to spell and doesn't look like it's pronounced. Isosceles. And when triangles are isosceles, it means they have two or more, which gets into an interesting kind of definition thing here. Two or more angles and sides the same. Congruent, you might say as well. Our final triangle over here is intended, probably isn't actually this way, but it's intended to be that all the sides and all the angles are exactly the same. And this is an example of an equilateral triangle. So in an equilateral triangle, all sides and all angles will be congruent, or the same. Now there's an interesting, like we said a second ago, definition issue here, because an isosceles triangle has the definition of two or more angles and sides the same, which actually includes equilateral triangles. So if I look at this triangle here on the right, it is both equilateral, because it has all sides and all angles the same, and isosceles, because it has two or more angles and sides the same. On the contrary, we've got the center one, which is isosceles. It has two or more angles and sides the same, but it's not equilateral, because not all the sides and all the angles are the same. So one thing we might say here is that an equilateral triangle is a type of isosceles triangle. So all equilateral triangles are also isosceles. It's a weird little triangle definition thing there. Scalene, however, over here on the left is totally independent. Nothing that's scalene is isosceles or equilateral. So the next thing we need to talk about are some important triangle properties. The first thing we're going to say is that a triangle is always going to have the same number of congruent sides and angles. So if a triangle has two congruent sides, it'll have two congruent angles. If it has three congruent sides, it'll have three congruent angles. And if it has no congruent sides, it'll have no congruent angles. So there's always a consistency there. Let me show you what I mean. Let's say, for example, that this is an isosceles triangle and that this side and this side are congruent to one another. They have the same length. Well, what we're going to find is that this angle and this angle will also be congruent to each other. So we'll have two congruent sides, two congruent angles. Similarly, if this is an isosceles and equilateral triangle, it'll have all three sides the same, and all three angles will also have to be the same. This works both ways. So if I tell you that these two angles are congruent and the other on the triangle is not, you'll know that the two sides are also congruent. The other thing we know about triangles is that the congruent sides and the congruent angles are always opposite one another. Here's what I mean by that. If this is an isosceles triangle and it has congruent angles here, and it has a congruent set of sides here and here, you're going to notice that the angles and the sides that are congruent are opposite each other across the triangle. So in a triangle, the angle will not touch the side that is going to be congruent. It's always going to be across the triangle. So not only do we know how many sides will be congruent if we know how many angles, we know which sides will be congruent. We could even take this one step further and say that the biggest sides are always opposite the biggest angles. So if I know in this scalene triangle that my right triangle is the biggest, I'll see that the biggest side is across from it. Same deal, this angle would be the smallest, and the smallest side is across from it. So it makes sense that equal angles have equal sides across from them. The last cool property of triangles we're going to talk about is probably the most important. The degrees of triangles, the interior angles of triangles, always sum to 180 degrees. So looking at this triangle here, I would know that the angle measurement there plus the angle measurement here plus the angle measurement there would equal 180 degrees. And this can be really helpful if I know two of the angle measurements and not another. Let's say the bottom two are 50 and 45. Well, I know at this point I have a sum of 95 degrees. And since I know that the sum of my angles for my triangle have to add up to 180, I know that that missing angle is going to have to be 85 degrees. And I can build on a lot of these ideas and figure out lots of things from very little information, or what might look like very little information to begin with. For example, this is an isosceles triangle. I see that two of the sides are marked as congruent. I know that because opposite angles, or sides opposite angles that are congruent will be all congruent, I know that the missing side here that I pointed to with the arrow is going to also be 70 degrees. And because I know triangles sum to 180, and I already have 140, this missing angle up here must also be 40 degrees. So I can use that 180 degree rule for triangles to really kind of fill out the angles of a triangle when I don't seem to know them all initially. I can also put that together with some things I've known before and find a lot of information, again, that I may not have necessarily thought I could find initially. Here, for example, I see that I've got a 130 degree angle, and while this isn't strictly a triangle, it does close into a full triangle. I've got three sides together. So I can start by finding this missing angle here, because I recognize that it's a supplement with this 150 degree angle. Therefore, the missing angle has to be 30 degrees. Again, using my 180 degree rule, I can say, well, if I have 130 and 30, I've got 160, so the missing angle must be 20, because again, all triangles are going to add up to 180 degrees. So I've been able to find all my missing angles. And here are your practice problems for the lesson. For numbers 1 and 2, you're going to use the triangles here on the right, and you're going to classify them first by largest angle, then by congruent sides and angles. And then for number 3, you have two triangles down here. You need to find the missing value of x. Good luck.